Hello, my name is Sam Mercer. I'm a rising junior chemical engineering major, and today I'm going to be presenting my startup, Eizent Software, and our 2021 Summer Sea Grant final presentation. I want to have a little disclaimer. Anushree Gurung, who won the Summer Sea Grant, was originally going to present this presentation, but she was unfortunately unable to come today, so I've come to take the podium, and I learned that about an hour ago. So this is very much a trial by fire for me, but I'm very excited to share with all of you the progress Eizent has made this summer. So let's get started with what is Eizent Software. A little bit of backstory first. Eizent Software started as a research project of mine I actually did in this room about 2 years ago. The project was titled Wireless Data Processing System for IoT, Internet of Things Enabled Devices, and the objective was to collect data from environmental sensors that could be deployed in the field, transmit that data wirelessly to the cloud, and then store it onto individual devices that were connected to the internet. And we called ourselves Eizent Innovations, and the big thing that we found from this type of development was it was a 5-phase data processing system, which when you hear that, you're like, whoa, that's complex. And when we built it, that was complex. It was comprehensive and multi-component, which meant that development-wise, we had to manage 5 different systems and work them concurrently together to build something that would synergize. But when we built a successful prototype that did that, that was great, but as an entrepreneurial venture and a startup company, that's very hard to manage and put all together at the get-go. So although we had a successful prototype, we had to meet it at industrial standards and also successfully deploy it in the field, which are 2 different things from theoretical in a laboratory to actually an application that people can use and buy reliably. So from the get-go, we had risky overhead costs because if we had to work with each individual customer to develop customized systems with our 5-phase process, that meant we were more so a consulting company instead of a product development company, which meant we would have to travel all around the country or the world to work with individual users at their individual sites. And unfortunately, that many plane tickets is expensive. And from that, if we were going to revise all 5 components, that meant we'd have to divide out our research and development time to build all 5 components, which was inefficient, and we likely weren't able to do until after we graduated. So today, we've revised Eizent Innovations to become Eizent Software. So instead of focusing on all 5 phases, we've chosen one part of the 5 phases and really developed and worked on that. We've completely overhauled our software over the summer. This summer, we revised everything for the one part of our system that we find most viable. And we've rebuilt the code for industrial use, and it has proven to be more secure and much more user-friendly when people actually apply it. We've also simplified the services and done this by using Amazon Web Services. Everything was customly built using a hodgepodge of different technologies that were somehow outdated as well, which wasn't really efficient. And finally, with this new business model, instead of working with each individual users to build all 5 phases, we now give them the capability to do that themselves without any coding. They download our software, they plug in their sensors that they want to utilize, and then we give them an application interface to customize the sensors, no coding involved, and it allows us to achieve our goal of using a 5-phase system to wirelessly connect devices, collect data, and make the world a better place. And by focusing on this one component from an entrepreneurial perspective, this helps build our value proposition. As we look at the component with the most value, we're able to optimize our development time and also really make sure that the product is exactly what users want in the near future. So in terms of lessons learned, there were 3 large lessons. Number 1, team communication. As a large team, back in January, we were about 9 to 10 different students all working on this project. It was very difficult to fit that in with academics and other activities people did outside of school. So if you're not able to have a good culture as a startup, it's very hard to work efficiently and really hammer in the development time. This summer, we've adopted the Agile framework, and we're able to move forward a lot faster and work as a great team. Number 2, comprehensive planning. At the get-go, looking 1 month ahead as to how our businesses do is great. Looking 1 year ahead is even better. But looking 5 or 10 years in scope may be the best way to build a viable business plan, because by looking in the future and having that predictive capacity to what we're able to do now and then, we'll be able to see along the way how many problems that we might have and predict them before they even occur. That way, we can minimize liability and operate as a better company because we know what's coming. And then number 3, the importance of partnership, mentorship, and industrial insight as a startup Internet of Things company. As with such knowledge and by working with customers and our mentors, we were able to learn and build a new mindset that really fit our purposes a lot better than amateurs that we were beforehand. And secondly, with that, by working with customers, we're really able to hone in on what they really want. We're engineers at the very basis, and we like to build lots of things. We like theory and that kind of stuff. But if it doesn't work how they want it, then it's not a viable business. Our largest success was definitely overhauling the web framework by reconstructing everything and having it exactly how we want it and how our initial alpha prototype testers want it. It was a lot better and user-friendly compared to our old system. But our largest frustration alongside with that was putting that together. That spent like 40, 80, 120 hours all towards the development time. But our team was able to manage it successfully. And moving forward over the fall and the upcoming year, we're still going to focus on software development and work with potential customers. That's our main value proposition. And by doing that, we're able to really hone in on what they want most. And then number 3, we want to add a couple members to our team that are interested in software development and also for sales and marketing. So for acknowledgements, I'd like to thank everyone that helped our team throughout the summer Sea Grant process. Ian Grant, Mike McClurkin, Heather McNeil, Jamie Baker at Pierce Atwood, and also Dr. Alex Antosta, who helped us expand our network, build our customer discovery framework, and also really help enhance our system for how she wants it as a potential customer. And there's a picture of Anu, who's done a tremendous job at Eizent over the summer and is unable to be here today. But it's also a photo of her at work this summer. Thank you.
What's your first alpha project? Where is it going to get applied?
Thompson Farm at UNH. We're going to collect snowfall data. So we're going to deploy the system based on the potential customer, and from that, see how far it's able to last inside the wilderness and see what kind of problems it might undertake. And we still haven't done a true alpha prototype test, so whether our system compromises at temperatures, high and low temperatures, or if some random animal decides to eat the cables. Those are realistic problems that we have to see if we're able to make it gradable.
So you're talking about how we need to build for the future, not the present. Where do you see the IoT device space in terms of research in 5 to 10 years? And how does that affect what you're doing now?
That's one of the big things that we looked at this summer, because IoT really emerged in 2010 along with like the technological renaissance. And it's constantly changing every year, the market demand and also innovation as itself. As technology develops, other competitors and other companies around the world are also trying to build these same types of devices. And when we looked at it as a market potential, there's 3 distinctions, because lots of people do like DIY, they do it themselves and build it themselves. But there's also governments that have agencies that develop all their custom systems and with their own security. So having something at Eizent is going to be very difficult to predict and utilize on like a federal scale, but also just for general users. As technology develops, how can we update our system so it's compatible with new technologies and new systems? So it's constantly changing, and that's something we're going to look into a lot more in the future.
Great.
Thank you.